Right, good afternoon. Your presenter this afternoon is Mr. James Munatsi, presenting the extended maths, the 0580-2141 or 2242. Now, today we are going to be looking at our coordinate geometry. Now, before I look at the coordinate geometry, let me give an outline as to where does the name coordinate geometry or the Cartesian plane comes from. Right, this was discovered by René Descartes in the 1596 to 1650. Was one of the greatest philosophers of his time. The word Cartesian is derived from his name and his work. And he was a soldier, by the way. So his work formed the link between the geometry and algebra, which inevitably lead to the discovery of the calculus, which is so popular today. So generally we are going to be looking at the coordinate geometry, and we shall look at the objectives, the lesson objectives. Now, number one, I'm saying the E31. This is according to the syllabus, our syllabus 0580. Right, as I say, stroke 21, stroke 42, where we have got the two papers. Now, for this particular lesson, we're going to be looking at these 6 lesson objectives. Number one, we have to demonstrate familiarity with the Cartesian coordinates in 2 dimensions. Now, this I'm going to presume that as extended students, everyone knows about the Cartesian plane. Right, the E32, 3.2. Find the gradient of a straight line. Calculate the gradient of a straight line from the coordinates of 2 points on it. So we should be able to define what gradient it is, and then to be able to calculate the gradient when we are given 2 points, right, from the point given. Right, the E3.3 is per syllabus. Calculate the length and the coordinates of the midpoint of a straight line from the coordinates of its end points. So in other words, when we are given 2 coordinates, we should be able to find the length of that particular line or the midpoint of that particular straight line given 2 points, or you can be given the middle point and the end point. We should be able to find the length of those particular lines. E3.4, interpret and obtain the equation of a straight line graph, right, using the standard form y is equals mx plus sc. Right, E3.5, determine the equation of a straight line parallel to the given line. So we should be able to, when we are given 2 parallel lines, we should be able to find the equations of those particular parallel lines. Right, E3.6, find the gradient of parallel and perpendicular lines. So when we are given 2 lines which are said to be perpendicular, we should be able to find their gradients, and hence one can find also the equation of those particular lines. So we move on to the next aspect. Right, as I said right from the beginning, I do hope that everyone knows how to define the coordinates. So, as my example 1, I would like to draw and label the graph of y is equals 2x minus 3 for values of x ranging from the minus 2 to the plus 4. Which as times I can write is minus 2 less or equals to x less or equals to 4. Now, let me go. I'm going to make a table. The coordinates of points on a line are calculated in a table. This is another way of drawing that particular line. So first of all, as I've said, I'm defining the values of x, which I said are from minus 2, minus 1, 0, 1, 2, 3, and 4. And then I find the 2x, I mean this particular 2x here, right, meaning 2 multiplied by the value of x. So 2 multiplied by negative 2, that gives me negative 4. 2 multiplied by negative 1 gives me negative 2. 2 multiplied by 0 gives me 0. 2 multiplied by 1 gives me 2. And then 2 multiplied by 4, 2 multiplied by 2 gives me 4. 2 multiplied by 3 gives me 6. And 2 multiplied by 4 gives me 8. So generally, that is where we are getting these particular values. And then the 3, since it doesn't have a variable, right, I am now going to be just writing minus 3, minus 3, minus 3. Now, I'm going to make a combination of that. What is 2x minus a 3? In other words, I'm saying what is minus 4 minus a 3 gives me minus 7. Minus 2 minus 3 gives me minus 5. 0 minus 3 gives me minus 3. 2 minus 3 gives me minus 1. 4 minus a 3 gives me 1. 6 minus a 3 gives me 3. And 8 minus a 3 gives me 5. So in other words, when I'm given the values of x, I should be able to find the value of y. Now, I'm going to connect this particular point. My first point is going to be minus 2, 7, minus 2 minus 7, minus 1 minus 5, 0 minus 3, 1 minus 1, 2, 1, 3, 3, and then 4, 5. Now when I'm going to connect, as I presume that everyone knows how to connect these particular lines, I'm going to now use my straight ruler and join these particular points. It will definitely give me a straight line. Now if it does not give me a straight line, that means there is a problem somewhere. I need to go back to that particular point and try to correct it. So these are called the linear equations, and therefore when I join these particular points, it will produce a line graph, right? So when I've done that, I have drawn and labeled the graph of y is equals to 2x minus a 3 for the values that ranges from minus 2 to 4. And this, in a nutshell, is my table of values that will enable me to be able to draw that particular graph. Now, we can do the same on the given exercise. So what I would like us to try is to produce the same table and draw the following graphs using the scale of 2 centimeters to 1 unit on the x-axis and 1 centimeter to 1 unit on the y-axis. Number 1, y is equals to 2x plus a 1 for the values of x ranging from minus a 3 to 3. Number 2, y is equals to x minus 1 for the values of x ranging from minus 3 to 3 as well. Number 3, y is equals to 3x minus 4 for the values of x ranging from minus 3 to 3 as well. Right, number 4, y is equals to 10 minus 2x for the values of x ranges from minus 2 to 4. Y is equals to 3 outside the brackets, which looks a bit different from the first. X minus 2 for the values of x ranging from minus 3 to 3. Number 6, y is equals to 2t minus 3 for the values of, is supposed to be for the values of t ranging from a minus 2 to 4, a point of correction, right? And then number 7, z is equals to 2 minus 3t for the values of t ranges from minus 2 to 4. So for us to be able to draw these particular lines, you can actually choose any variable. It can be x, it can be y, it can be z, it can be t. And we should be able to come up with a table of values, and out of that particular table of values, we can find the corresponding values of y. And using our graph, as I presume everyone knows, we are going to connect those particular points and of course join them with a straight line, with a straight ruler rather, and then it will produce our straight line graph. And that is simply how we should be able to draw the graph given an equation, and then we come up with a table of values. Now let's move on to the other values in question number 8 and question number, question number 8 and question number 9. Question number 8 has got, this should be question number 9 rather. So in each of the following questions, draw the graphs of on the same page and hence find the coordinates of the vertices of the polygon formed. In other words, this formed shape is going to be a polygon that is many-sided, and give the answers as accurately as the graph will allow. So we are going to, at this particular point, draw the line y is equals x, y is equals 8 minus 4x, number C, y is equals 4x. Now we are going to take the values of x from a minus 1 to 3 and the y values from a minus 4 to 14, and therefore it will enable us to be able to draw those particular graphs. So we'll try the number 8 A, B, C, and then number 9 A, B, C as well. Right, now we move on to the next part to find the gradients of a line. Now the gradient of a straight line is the measure of how steep it is, right? And sometimes some can say the gradient of a line is the difference in the y coordinates to be divided by the difference in the x coordinates. Now what do I mean? Some commonly they say gradient is y1 minus y2 over x1 minus x2. Now normally there is a problem where people start with the x coordinates divided by the y coordinates. So we should know always we should start with the y coordinate, the difference in the y coordinates to be divided by the difference in the x coordinates. Now let me look at an example. Right, find the gradient of the line joining the points A, which is 1, 2, and B, 6, 5. Now the solution, I say gradient is called the difference in y coordinates to be divided by the difference in the x coordinates. Now which ones are my y coordinates? I've got 2 here and I've got 5 there. So I should find their difference. In other words, I'm saying 2 minus a 5 to be divided by the difference in the x coordinates. Which are my x coordinates? 1 here and 6. Right, 1 and 6 are my x coordinates. Therefore, their difference, I'm going to say 2 minus a 5, that gives me a negative 3. And then 1 minus a 6 gives me negative 5. Now, since the numerator and denominator have got negatives, a negative divided by a negative gives me a positive. That's why my final answer we have 3 divided by 5. So this answer can be written as a fraction, or if I want, I can write it as 0.6. So the gradient of this point AB is 3 over 5, or as I say, you can write them as 0.6. Now let's move on with my example 2. Right, I want to find the gradient of the line joining the D, which is 1, 5, and an E, 5, 2. I'll do the same. Now here I'm not going to be writing the formula, but since I know my y coordinates has to be on the numerator and then my x coordinates on the denominator, I would therefore say 5 minus 2. 5, I'm talking about this particular 5 here because that is the y coordinate. Sorry, let me take you back. Right, this I'm talking about this particular 5 here, and then minus this particular 2 here to be divided by the 1 minus the 5. Now normally there is a problem which people make. When I take the first 5 in this particular D, I should also take the 1, the 5 being the y value, I should also take the 1 being the x value from the same D. So 5 minus a 2 to be divided by 1 minus a 5. So 5 minus 2, which gives me the 3, and 1 minus 5 gives me the minus 4. Now, one is now wondering, why is it that the negative is now on the numerator? It's no longer on the denominator, because on the 3 there is a positive, and on the 4 there is a negative. So I'm saying the positive divided by negative gives me the negative. That's why the negative is now on 3, and sometimes the negative can be in line with that particular line of division, and therefore the gradient of this particular line is negative 3 over 4. Now we need to take note of these particular 2 points. The lines which slope upwards to the right are positive. In other words, a line of this particular nature inherently positive gradient, and the line of this particular nature inherently negative gradient. So we need to take note that the lines which slope upwards to the right, they have the positive gradient, and the lines which slope downwards to the right have a negative gradient. So these 2 aspects will generally make you be aware as to the nature of your particular line. Now let's move on to the next one. I want to find the length of the line segment. The length of the line segment, or in other ways, the line joining the 2 points. For example, I have got, find the length of the line segment drawn from P, which has got the coordinates 2, 1, to Q, which has got the coordinates 6, 4. Now, by formula, I'm going to be using the Pythagoras theorem. Now, I'm saying, find the line segment, I'm saying the square root of the x values, which is the difference in the x values squared, which is 2 minus a 6 squared, plus the difference in the y coordinate squared, 1 minus a 4 squared. Now, then, if I'm going to square that one, that will give me, I can do with my calculator directly, and that is going to give me 5 units. I'm not going to say 5 kilometers or 5 meters, but the units are given as 5 units, right? So, in other words, after having calculated that, minus 2 minus a 6, that is minus 4 squared, which gives me 16, plus 1 minus 3, the minus 4 gives me minus 3 squared, that gives me 9. And therefore, 9 plus this 16, that gives me 25. And therefore, the square root of 25 gives me the 5 units. Now, as I said, this is typically applying the Pythagoras rule. We typically apply the Pythagoras rule. So, generally, that is how I find the length of the line segment. So, in other words, if I've got the x1, y1, and then the x2, y2, what I'll simply do is the square root of x1 minus x2 squared plus the y1 minus y2 squared. And then the square root of that will give me my final answer. But in terms of these particular variables, there is no way I can find the length of the line segment anywhere. I cannot say, because they are variables. They are x and y variables. Now, we can also try this as an assignment. Draw a pair of x and y axes and plot the points A, 1, 2, and B, 7, 6. And find the length of the line segment. Right? Find the midpoint of the line joining AB. On the graph, plot the points P14, Q48, and R51, and determine whether or not the triangle is isosceles. Now, I do hope that everyone knows what an isosceles triangle is. The base angles of an isosceles triangle are equal. In other words, it should have the two of its sides equal. And then find the coordinates of the midpoint of our PR. So, we can try number 1 and number 2 and see, applying our theorem of the length of the line segment, we should be able to find the length of the line. And don't forget that we are giving our answer in units, not in kilometers or meters. Now let's move on to the form. An equation can be written in the form y is equals mx plus c. Now when the equation of a straight line is written in the form y is equals mx plus c. Now this particular m that you see here stands for the gradient, and this particular c here stands for the y-intercept. Now, what do I mean by y-intercept? I mean where the line cuts the y-axis. So, given an equation in its standard form, you should be able to know its gradient, 1. Number 2, you should be able to know where does the line cut the y-axis. Now, for example, I want to draw the line y is equals to x plus 3 on a sketch graph. Now, there is a word sketch here. We need to understand what exactly do we mean by sketch. Now I say the word sketch implies that we do not plot a series of points as we were doing like in the first, but simply show the position and slope of the line, right? Because here I should be able to know that this particular 2 is the gradient of the line, and I also know that this particular 3 is the y-intercept. And therefore, my line of thought is the line y is equals to x has a gradient of 2, as we have said, from y is equals mx. This intercept, this particular point represent the gradient, and this is our intercept. So in this particular case, our gradient is 2, and the intercept, it is cutting the y-axis at the point 0, 3, because it is on the y-axis. And the slope on the line, it is upwards to the right because it has got the positive gradient. The same line cuts the x-axis when y is equals to 0. So it is very important that, number one, we should be able to determine, when you are given the line, what is the gradient of that line. Number two, where does that line cut the y-axis? So it is the gradient and the intercept that matters the most in drawing any particular line or in putting any equation in the form y is equals to mx plus c. And we call this one the standard form of equation. Now let's move on to my example 2. Right, draw the line x plus 2y minus 6 is equals to 0 on a sketch graph. Right, and then number 2, for me to be able to do that, I should, number 1, rearrange the equation to make y the subject. Now, x plus 2y minus 6 is equals to 0. If I rearrange the subject, I should make sure that y is the subject of my formula. Now, the 2y should remain on its own, and then I transfer all the numbers on the right hand side. So it gives me the 2y is equals to minus x. Why minus x? Because this was a plus x. When it crosses the equal sign, it becomes a minus x, and then plus a 6, y plus a 6, because the minus 6 is crossing the equal sign and therefore changes its sign. Now, but I want to make y the subject. In other words, y should stand on its own. Therefore, for me to do that, I would now divide both sides by 2. So y is equals to minus 0.5x. Now y minus 0.5, I can write it as minus 1 over 2, which gives me 0.5x plus, since I'm dividing everywhere by 2, that means 2 into 6 gives me that particular 3. So this particular line has now been written in the standard form y is equals to mx plus c. And out of here, I should be able to know that minus 0.5 or minus half is my gradient, and this line cuts the y-axis at the point 0, 3, or at the point 3 in a way. Now, this explains my gradient and my intercept on the equation. So we should be able to find that particular y-intercept. When you are given an equation, it is very easy to determine the value of the gradient and to determine the y-intercept as well. And as I have explained before, if the equation is not in standard form, it has to be rearranged in such a way that y stands on its own, or y is the subject of the formula. Now we move on to the next part of our topic, finding the midpoint coordinates of a line segment. Now I always start with my example. I want to find the coordinates of the midpoint of a line segment which joins P to Q. Now my P has got the coordinates 2, 1, and my Q has got the coordinates 6, 4. So the midpoint coordinates, in other words, the center coordinates of the line PQ is going to be 2 plus a 6 over 2. Right? Why 2 plus a 6? Because these are the x coordinates. So the product of the x coordinates, or the sum, no, not the product, the sum of the x coordinates divided by 2, and then the sum of the y coordinates divided by 2. So in other words, that's why I say it's 2 plus 6 divided by 2, and 1 plus a 4 divided by 2. So 2 plus a 6 gives me 8. 8 divided by 2 gives me 4. That's where that particular 4 is coming from. And 1 plus a 4 gives me 5. 5 divided by 2 is 2.5, or 2.5. So the midpoint coordinates of this particular line is therefore 4, negative 2. Now, in a nutshell, the coordinates of the midpoint of a line joining 2 points is given by the sum of the x-axis divided by 2 and the sum of the y-axis divided by 2 as well. So mid, you divide by 2. Now let's look at this example. Find the coordinates of the midpoints of a straight line joining the pairs of the points. I have given my number 1, A, B, C, D, E, and F. Now when we are dealing with, for example, we are looking at number E, we need to be very careful in dealing with the negative numbers, right? Positive numbers, there is no problem. For example, number 1, A, one can simply say 4 plus 1, which is 5 divided by 2, which gives you 2.5. That gives you the x coordinate. And then the y coordinate, you simply say 3 plus 5, which is 8. 8 divided by 2, that gives you 4. And therefore, you have your 2.5 or 2.5 and 4 as the midpoint coordinate. Right? Now, number 2 looks a bit different, and it actually is thought-provoking. Now, M is the midpoint of a straight line joining A, 11, 6 to the point B. If the coordinates of M are 7, 5, find the coordinates of B. In other words, we are given the midpoint coordinates, and then we are given the point A, and what we would like to find there are the coordinates of point B. So we need to play around with this particular formula and find the coordinates of B, and that is a thought-provoking question. Now let's move on to our next part, finding the equation of a line. Right, I have earlier on said the equation of a line are in the form y is equals to mx plus c. So suppose we are given 2 points. For example, find the equation of a line which passes through the point 1, 3 and 3, 7. Right, and then I said for you to find the equation of this particular line, let the equation of the line take the form of y is equals mx plus c. So it is advisable that most of our equation should be in standard form. Now the first thing that I need to find, as I say, this m here stands for the gradient. Right, it stands for the gradient. So what I'm going to do is find the gradient of this particular line. And then number 2, I need to know the y-intercept. Where does this line cut the y-axis? Now, I want to find the first, the gradient of this particular line. And as I know, and as we know, we said y1 minus y2 over x1 minus x2. And sometimes we can even say y2 minus y1 over x2 minus x1. So in this case, I'm starting with my y2. So 7 is my y2 minus a 3 to be divided by a 3 minus a 1. So 7 minus a 3 gives me a 4, and then 3 minus a 1 gives me 2. 4 divided by 2 gives me 2. So the gradient of this particular line is therefore 2. So we write the equation as y is equals to 2x plus a c. Now why am I writing 2x? Because I already know the value of my m, which is the gradient of this particular line. I already know the gradient of this particular line, which is my 2x. But I don't know the y-intercept, which is the value of my c. So since the line passed through the point 1, 3, so in other words, why did I choose 1, 3? I can even choose the 3, 7, or I can choose the 1, 3. It depends on me. Whichever point I want to choose, it will give me exactly the same point, the same equation. So I've taken the point 1, 3. I'm going to substitute 3 for y and 1 for x. In other words, this stands for the x value and the 3 stands for the y value. Now I'm going to substitute them into the given equation. Therefore, under y I'm putting 3 is equals to 2 multiplied by the x value is 1, and then plus c. Now my main aim here is I should be able to find the value of c, so that I make my equation a complete equation. Right, so 3 is equals 2 multiplied by 1 gives me 2 plus a c. If I'm going to take 2 to 3, that gives me 2 minus a 3 minus a 2 gives me 1. Therefore, the value of c is equals to 1. And now that I've got the value of m and the value of c, I can simply now say the equation of my line is y is equals to 2x plus 1. So when given two equations, when given 2 points, rather, I'll be able to find the equation of the line and put it in the form y is equals to mx plus c. And as I've said in a nutshell, it is very important that I should be finding the value of m, which is my gradient. And when I've got the gradient, I can choose any of the 2 points and substitute them into the equation. This enables me to find the value of c. And therefore, I make my equation a complete equation. Y is equals to 2x plus a 1. And as I have emphasized, it is very important that this particular equation is put in standard form. Y is equals to mx plus c, as we have talked about earlier on. And therefore, it is very simple. My gradient of the line is 2. My y-intercept is 1. In other words, this particular line cuts the y-axis at the point 0, 1, and its gradient is 2. And when I've done that, I'm done with the equation of the line. Now, we can try these 3 problems. Find the equation of the line which passes through 0, 7 at the gradient 3. In other words, the gradient is 3 and it is passing through the point 0, 7. Now that you have got the gradient, it is very simple and you should be able to put your equation in the form y is equals mx plus c. Because already you have got the value of m, and all what you need to do, you are now going to find the value of c using this particular point. Right, number 2, find the equation of the line which is passing through the point 2, 1 and 4, 5. Right, we are going to be doing exactly this. Now that I don't have the gradient, I should be able to find the gradient of the line, right? Using my y1 minus y2 over x1 minus x2. Or simply the difference in the y-coordinates to be divided by the difference in the x-coordinate. That will enable me to get the gradient. So when I've got the gradient, I now express y is equals to mx plus c. Now that the gradient is known to me, I can choose between the 2 points to find the value of c. I can take 2, 1, or I can take 4, 5. It all depends which point I want. But I should take a point that is very comfortable with me. Right? And number 3, find the equation of the line passing through the point 6, 0 at the gradient 0, 5. This particular 0, 5, you can say 1 over 2, depending on which point you want. You can put it as a decimal, as it is, or you can put it as a fraction, as it is. Right? So, there is no problem. It is just like number 1. Number 1 and number 3 are almost the same because you are given the point and you are given the gradient. And therefore, y is equals to 0.5x and then plus c. And then substitute the 6, 0 into the equation. That will enable you to find the equation of the line. And don't forget, we said it has to be in the form y is equals to mx plus a c. So that is finding the equation of a line given 2 points, or you can find the equation of the line given a point and its gradient. So the main formula is y is equals mx plus a c, and this will enable you to find the value of m and the value of c, which is the gradient and its intercept. Now finally, we are going to be looking at perpendicular lines. We are going to be looking at perpendicular lines. Now, when 2 lines are said to be perpendicular, that means these 2 lines meet at an angle of 90 degrees. So if the gradient of m, which is another line, is equals to 2, then its perpendicular line gradient is equals to minus 1 over 2. Now, what am I saying here? I'm saying the product of their gradients should be minus 1. The products of the gradients of perpendicular lines should be minus 1. For example, if I'm given that the gradient of this particular line is 3 over 4, That means of its perpendicular lines is going to be minus 4/3. In other words, the numerator now becomes the denominator and the denominator becomes the numerator. Or their products should give you minus 1. When you multiply the products, when you multiply the two gradients, they should give you minus 1. And it is the reciprocal of the gradient of the given line, right? But not forgetting that you need to put a negative number. For example, or as an exercise rather, find the gradient of the line which A passes through 3, 4 and is perpendicular to the line y is equals to x plus 2. Now, it is very simple. You need to know the gradient of that particular perpendicular line. This particular line here, the gradient is 1. That means the other line, which is the perpendicular one, its gradient is supposed to be minus 1. Because when you multiply 1 multiplied by minus 1, it gives you minus 1. So you are now going to be using this particular point using the formula that we have been using before in the form y is equals mx plus c. And that will enable you to find the gradient of the line which passes through the point 3, 4 and is perpendicular to the line y is equals to minus y is equals x plus 2. So in other words, we are saying the gradient of this line is 1. And what about its perpendicular line? It has to be minus 1. Right, and then number 2, find the gradient of the line which passes through minus 1, 0 and is perpendicular to the line through 3, 1 and 5, 7. So what we simply need to do is to find the gradient of these particular 2 points and then find its perpendicular line, which we say if you are going to multiply those two, they are going to give you a minus 1. So the product of the gradients of perpendicular line should be minus 1, right? So when the gradient is 2, for example, its perpendicular line has to be minus 1/2. If the gradient is 3, that means its perpendicular line has to be minus 1/3, right? In other words, in simple terms, the numerator becomes the denominator and the denominator becomes the numerator. Now, having looked at those particular points, I think that will see us having to look at our objectives, our lesson objectives of today. And we can, as a hint, it is very important that we look at the questions from the past papers, various past papers, and relate them onto the outlined objectives. Thank you very much, and I do hope that you enjoyed the lesson.